Okay, so we're back. So we have our hotel pricing policy. We want to just take a look at a solution. And then we want to take a look at the parts of we want to take a look at the parts of what you call this thing, flow chart, and maybe even convert this into a flow chart. Okay, so we have the hotel pricing policy as follows. We know that we have an integer for the number of people, right? We know that we have a real number for the price, and we can, declare some variables from there afterwards. So we can start and we can say that we can print a value, print out a message asking how many people are staying. And we will then input the number of people. Everybody with me up to this point, right? So we then know that according to the amount of people, so if the number of people is less than or equal to 2, right? If number of people is less than or equal to 2, then we want to set the price to be 85. Else if the number of people is equal to 3, everybody got this price, this correct? Price is equal to 90. Else if number of people is equal to 4, we have the price being equal to 95. Remember, when we are representing these numbers, we are representing them as the integer values. We could always append the $sign using a printf statement afterwards, right? So that's just a nod. So we're not putting any $signs there. And the price, of course, is a floating point value because we have to accommodate for potentially later on getting a floating point result inside of here. So else, and what is this else means that once the number of people is more than 4, we do that $6 per person that we previously discussed. So we say else price is equal to 95 plus number of people minus 4 right, multiplied by 6. So what do we get here? We get the amount of people that for each extra person, we adding $6 to the price for that person. We put the end if here. So just want to note, for everybody to note, again, my indentation, it's essentially telling me what statements are under the control of the statement above. When I return back to a particular indentation, that tells me where my control now switches over to. So, this indentation is something that we have to practice to ensure that everything is fine. Okay. So let's see if we could use some sequence again to work out the discount. The thing is, we can ask first, we could say print is anyone over Is it 60 or 65? 60 or 65? 60. Is anyone over 60? All right. Is anyone over 60? You could input age, and age, of course, could be a Boolean. So we could say Boolean age, and we also have business, right? So is anyone over 60? Input age. If age is equal to true, right? Or if age is equal to yes, because it's a pseudocode algorithm, we can write true or we can write yes in this instance as a response there. Okay, we'll use true, right? Discount is equal to discount is equal to 0.85. All right, so I have a real for discount. Okay. And what I could do is I could set discount to be equal to 1 in this instance here, up to the top. And then I could do the same thing for print. Are you on business? Are you on business? Input business. If business is equal to true, discount is equal to 0.80. What did I do here? What did I do here? What I did here was that I said to myself, okay, I asked first if anybody is over 60. If anybody is over 60, I set the discount to apply to be 0.85, which is 85% of the original fee, 15% off. Otherwise, I said, are you on business? If business is true, the discount then goes down to 80. So then the last thing that I could do before I print the actual price, or when I print the actual price, okay, is I could work out what the final price is by saying price is equal to price multiplied by what happens here? If it is that my over 60 value, if this was no or false, then discount would have still been 1. We would not have changed this value. If we're on business, if business was false, discount would have stayed at 1, so we wouldn't have changed this value. So when we do this piece of code here, price is equal to price multiplied by discount, we say if the price, let's say, was 95, we have 95 multiplied by 1, which is 95. It doesn't change. But if it is, say, for instance, that over 60 was true, right? So this was true. Then the new price, the new value of discount is 0.85. And 0.85 now has 0.85, which will give you, right? Well, 85% of 95, which is the price now changes to 80.75. I see a hand up.
Yes, sir. I just wanted to know if you wasn't gonna put the are you on business above the anyone over 60.
Right. The reason that I put it in this order, right? The reason that I put it in this order is that it facilitates both of them being true. Because this is the bigger discount. So if this is true, then discount would have been 15% here. But then if this is true, your discount expands to 20%. So when you do this final calculation here, you get the 20% discount. I use the sequence in my favor here. You understand my logic behind that?
Yes, sir. Yes, sir. That makes real sense.
Okay. So, this is why we we would have thought it through. Of course, and I'm saying it, and you will hear me say this throughout our time as programmers and learning to program. This is not the only way to do this. Okay? There are many other ways that we could do this, that we could implement this. And this is just one technique, and we've decided to use sequence in this instance here. But we could have done this using nested loops. We could have done this using further logic. Okay, so there is no one way to achieve a correct solution when programming. So you and your friends might be able to, and I encourage people to work together, right? Everybody, once we could work together, I am not the only person in class who could help you. Okay, you can help each other. And you can help and learn from each other by sharing your answers, and not for tests and stuff like that. When we let me say that one time, Don't get up in the middle of my exam and be like, sir, say we could share answers. And no, right? Share answers time and place when we practicing and stuff like that. We can share answers, and you look at your friends' implementation and you could learn from them, and vice versa. Okay, I see one more question, one more hand up, Porter.
Yes, sir. For the age part, if I had used int instead of boolean, so I would say if age is more than 60, and then have the discount, would that also work?
Yes, yes. You could use that there. You could say if age is greater than or equal to 60, or greater than 60 or whatever, right? So yeah, that would have worked here too.
Say, I have something to ask about what Porter just said, right? He said like input the age. So does that mean that you have to input the age of every single person?
No, you could just ask, could you enter the age of the oldest person? And that would work. All right, so this is a solution that I am 100% sure will work. Okay, so in the event that somebody is over 60 and on business, they still get the better discount. In the event that they're only on business, they get the 20% discount. And in the event that they're only over 60, they get the 15% discount. All right. Any questions before I move forward? No? No more questions? All right, so I want to move forward and speak about flowcharts. And we wanna take a look at making some flowcharts. We have some flowcharts. What are flowcharts? Flowcharts are a way to diagrammatically express or represent the logical flow of an algorithm. We know that there are two other ways. You can write out an algorithm in plain English, like a piece of prose, and have it explain what goes on. And then we just created a pseudocode algorithm. A flowchart is a way of creating an algorithm diagrammatically. So in order to create a flowchart, we use some particular symbols. We have the start and stop symbol. Okay, so you could use this to start / stop a value. I'm sorry, a flowchart's logical flow. You put the word start or stop inside of the oval. We have the input-output box for the flowchart. So once you want to represent information to the user, or if you want to take information from the user and store it into a variable, we use this input-output box. And we put the operations associated with it inside of the box. We have a rectangle, which represents a process box. So a process box could be used for initializing a variable with a value. It could be used for doing some sort of mathematical operation. Okay. As well, it could be used to represent some logical instruction that is taking place, right? That, you know, it's not made for decisions because we have a separate box for decisions. And our decision box is a diamond-ish looking box, right? Okay, so that's much better. So this is a decision box. And the decision box has a condition inside of it. And it takes one input and it provides two outputs. One labeled true and one labeled false. So our condition box allows us to have multiple branches based upon the satisfaction of that condition. Okay. Then we have, of course, the flow lines. We have the flow lines. Which allow us to follow the logic of the what you call it, the flowchart itself. This shows what is the next step. You have to include the arrowheads, okay? You have to include the arrowheads. Because if the arrows only always go in one direction, because we always move from start to stop in the flow of the or in the execution of the algorithm. And then we have some two utility sets of symbols, which are connectors. So we have on-page connectors. And we have off-page connectors. And these have numbers inside that match up with each other, right? One connector, of course, will take an arrow going in and one connector will have an arrow coming out. And the on-page connector will, of course, connect the flow of logic where you mightn't have space left to put some sort of symbol, but you have space somewhere else on the page. And the off-page connector is if you have multiple pages and you want to continue the flow of that algorithm or of that flowchart. Okay, so we have these connectors here that allow us to create our flowchart. Now, there are other symbols used in a flowchart, right? But these are the ones that we will be focusing on. So you might go online and you might see a hexagon for a bounded loop, or you might see in some instances some people have flowcharts that represent data stores, and there might be flowcharts that represent modules, etc. And maybe I should show that one to you, right? This is one that we might use later. Okay, This is a float, a box that a module slash function box. And later on, I will give you all the usefulness of the module slash function box. Okay, but these are the symbols that we use most frequently in our flowcharts. And we want to just go back to that same exercise and perform a flowchart or do a flowchart. Okay? Any questions on the symbols? Any comments on the symbols?
No, sir.
No, we're good. All right. Good. So let's go back to this algorithm and see if we can represent this algorithm using a flowchart. Okay? Let's see if we can represent this algorithm using a flowchart. So we want to start, and all of our algorithms have this start. All of our flowcharts start like this, right? And what we can do is that we can use a process box to declare our variables. Okay, so we had int number of people. We had real price and discount is equal to 1. And notice that this discount being initialized with a value of 1 was really important to us, because later on, having a value assigned at creation, in the event that this was false and this was false, this over 60 and the in the event that the over 60 was false and the business was false, it went with the default value of 1. Okay, so that declaring the discount of 1 had a purpose. Okay, and then we had our Boolean variables.
So,
yes.
What's the first variable you put there?
Number of people, NUMPPL.
Okay.
All right.
Oh.
So, yes.
So you could just go over why you decline the discount to 1 again?
Right. So if it is that the discount value did not have an initial value, then discount as a variable would have been undefined. Now, we assign the value of 85.85 to get our discount at this point, or we assign a value of 0.80 at this point. But if it is that it was not there, then you would have whatever price you have, 95, multiplied. Let's say this was false, and let's say this was false. You would have had 95 multiplied by an undefined amount, which would have given what as an answer? An undefined value, right? So let me ask it like this. Emmanuel. Yeah, you there, right? Emmanuel?
Yes, sir. My mic is still long to turn on sometimes.
Oh, okay, no problem. Right, but then don't silence it just yet. I'm going to do something. I'm going to ask Anaya to think of a number. All right? Anaya, you thinking of a
Okay.
number?
Yeah. It
No,
have a
say
root for the number.
no, you can think of any number.
Positive or negative?
Positive or negative.
Okay.
Right. You have your number, Anaya?
Yeah.
Right. Emmanuel, multiply Anaya's number by 7.
All right.
Easy stuff, Emmanuel,
Yeah.
easy stuff.
Easy stuff. Let me get the answer there, sir.
You're going to give me an answer.
49, sir.
49. Anaya, is Emmanuel correct?
Nah, that's not.
Right. And the issue here, and it would have been freaky if that was the correct answer. Right. So thank you, Emmanuel, for making an attempt. But the answer here is that Anaya never defined her number for us. And it's kind of like the same thing in this instance, where if discount wasn't declared to be 1, an absolute value at this point, then when we needed it down here, if we never defined it as 0.85 or 0.80, what would it be? Understood? So again, this is sequence. We can't multiply a number that we've never defined. And actually, in some instances, depending on the language that you're using, and the tool that you're using to create this program, the compiler might tell you, well, you have an error because the number for discount was never defined. But luckily, we did define it as 1 here. So in the event that 0.85 or 0.80 wasn't reset to that variable value, we know that the price stays the same. We can't make that assumption. We have to be able to do that as programmers. We have to say, hey, this is what the value is. Everybody understand and everybody's with me? Yes or no?
Yes, sir.
Yeah.
Yes. Good, good. Great.
Yes.
All right, so we have the input-output box next. All right, and the two things could go in the input-output box because they're two statements next to each other. So we have print, right? How many people? I'm just using shorthand because, you know. And then I have input, num people. All right, and the next thing that we do moving forward is that we start this structure, this if else structure. And we can only make one decision at a time. So we can go like this. We start off with the first one. Num underscore PPL, sorry. Num underscore PPL is equal to 2. And it's either it is or it isn't. So what do we do if num people is equal to 2? Or less, sorry, not equal to, but less than or equal to 2. Right? We have to branch off. We have to branch off if it's true. If it's true, then we have a statement, a process box that sets price to 85. If it's false, then we go on to check the next process. Is num people, NUM underscore PPL equal to 3? If that is true, then what do we do? Right? If that is true, then we have to set the price to be 90. If it's false, then we check to see what happens if num people, you all seeing a kind of consistent, consistency is in terms of what we're doing here, right? Because programming is pretty consistent. If it's true, we set the price to equal to 95. If it's false, remember our arrowheads. Sometimes I have problems remembering arrowheads, but arrowheads really important. If it's false, then what do? Right? Then we don't check anything again further. If it's false in this instance, we have to say that the price is equal to 95 plus num underscore people minus 4 multiplied by 6. And so we have everything that we need to do inside of here. But where do we go from here? The next thing that we have to do is that all of these different choices then lead back to the same place after you do your choice. What is the next thing that we have to do? We have 2 more choices that we have to make, right? So we ask the choice, we have an input-output box, and that asks us, right, I just put in the input age. And after we input the age, it took us to a decision logic box. And it says age is equal to true. And if age is equal to true, what happens? This is one of those boxes where if it's true, something happens, and if it's not true, then nothing happens, nothing changed. Okay? So if age is equal to true, then we set discount to 0.85. Discount is equal to 0.85. If it wasn't true, what do? Well, we move on to the next thing, which was to input business. All right, so that should be input business. And again, we do the same thing. For business, if it's true, we have a change. So we ask a choice after we input business. Is business true? Business is equal to true. If that statement is true, then we have to set discount to a different value. Discount is equal to 0.8. Right? If that was not true, then we just move on. If this was false, and this is false here, if this was false, then we have price is equal to price multiplied by discount. And this should have gone on to here. So we have 2 sets of boxes that if it's true, you do something. If it's false, you just move on. All right. And then the last thing that we have is an input-output box for the total price. So we have an input-output box for the total price, which says print total price, comma, price. And so this came on from here, and the last thing that we do is stop. So when we zoom out, we have this diagram that we could follow. And we have to stay mindful that there should be no point along this diagram where any arrow goes to something that does not eventually lead to the value of stop. So in this first structure that we have up here, only one choice out of 4 could get done. Down here, when we follow down here, we input the age. We could either do something based on the age or not. Then we input business. We could either do something based on input based on the input of business or not. And then at the end, we get the total price shown. Okay? Everybody is comfortable with this? Anybody have any questions about what I've put on the board in terms of doing a flow chart?
No, sir, I understand.
Okay, good. All right, so you know this would lead into homework and our first coursework assignment, right? Yeah. So, all right, so we have a nice, simple coursework assignment, and well, I can't stop because I already start saying, but it's on video, right? You could work together, because at this point, it's more important that we understand by working together. So for this coursework assignment that I'm putting here, which is based on doing a pseudocode algorithm and a flow chart, I want that the objective is that you choose to work together, or you could do it by yourself. But this is for understanding, but it's also for marks. Okay, I kind of had to merge them together. But it's for understanding and it's for marks, so I don't mind if you guys work together, if you consult somebody else on this coursework assignment that's coming up. All right, it'll just be about two of these if statements that we're drawing coursework assignment for. I might put one for bonus marks. That might be there as well, so you could get extra marks. But it's important that we attempt this and understand it, okay? So anybody have any questions before we leave? Today we did the decision logic structure, and we did the flowchart associated with the decision logic structure, right? Next class, we're going to do a little more decision logic and then go into looping. And also maybe we can get to doing a flowchart for a loop. I see Clement has a question or a comment. Yeah.
Yes, my turn.
Yeah.
I just want to ask, I don't know if I'm missing like how much people do it.
If you're missing any what?
Like every weekend, so what's the largest amount of people could have in one?
I honestly, I wouldn't recommend that more than 3 persons work together on it. Because anything more than that, especially with programming and the flowcharts, it tends to be that people kind of, some people might fall behind and just observe rather than participate. So if it is that you're working, I would suggest peers or a group of 3, but nothing more than that, right? Otherwise, anything more than that, and it feels like, you're just sharing answers. So, I would always recommend that everybody attempts it by themselves first, and then you can come together and say, okay, this is what I have, how you get what you have, where is it different, And the thing is, as I said before, even when you're comparing in groups, you can have 2 different looking solutions and both of them can be correct. So it is possible to achieve a correct solution in different ways. Yes, Anaya?
I was just wondering about our next class. Is online or is physical? Because I remember you did say something last week about that.
Well, right. I did want to bring you all out. And let me stop the recording at this point. All right.